In this identity, we have sine of theta over 1 plus cosine of theta plus 1 plus cosine of theta over sine of theta equals 2 cosecant of theta. Clearly, the expression on the left is the more complicated, and so we're going to try and simplify this side so that it equals the right-hand side. What we should notice is that I have the sum of two fractions. It's best to try and write this as a single fraction. We can do that by finding the least common denominator. So, in the first expression, sine of theta over 1 plus cosine of theta, I'm going to multiply by sine of theta over sine theta. And in the second expression, I have 1 plus cosine of theta over sine theta, and I'm going to multiply by 1 plus cosine of theta over 1 plus cosine of theta. On the left, we get just plain old sine squared of theta. Here, I need to say 1 times 1 is 1. Outer is cosine theta. Inner is cosine theta. So that's plus 2 cosine theta. And then the last is cosine squared of theta. And this is all going to be over my common denominator, sine theta, times 1 plus cosine theta. Now what we should notice is that in the numerator I have sine squared of theta plus cosine squared of theta. Sine squared of theta plus cosine squared of theta is 1. So I get 1 plus 1 plus 2 cosine theta over sine of theta times 1 plus cosine theta. 1 plus 1 is 2, so I have 2 plus 2 cosine theta over sine theta times 1 plus cosine theta. Factor out your common factor of 2 there, and then you get times 1 plus cosine of theta over sine of theta 1 plus cosine theta. You can see that the cosine thetas are going to cancel out, and I end up with 2 over sine of theta, but whenever you're dividing by sine of theta, or 1 over sine of theta is equivalent to cosecant of theta, so I have 2 cosecant of theta, which is what the right-hand side of the expression is equal to, so I've established the identity.